Hello everyone. We are starting with today with lesson 7-4 on page 219 of your math journal, and we're going to look at parentheses, or what we call in Canada brackets. I will only make one video for the 6 pages that we have today. As you can see, I wrote it on the page. Today's work will also be extended to tomorrow. I have noticed that a few people in class have fallen behind simply because they're trying to get back into the routine of working daily, and some of them were not aware of their responsibilities until recently, so they're a little bit behind. I've decided to actually just kind of free up Friday so that you can do any work that you did not get done throughout the week. So to continue with the lesson, we're going to look at the rules of PEMDAS again. P-E-M-D-A-S. We've reviewed this already, and we know that P stands for parentheses. E for exponents, M for multiplication, D for division, A for addition, S for subtraction. This is what we call the rule for order of operation, which means this is the order in which we should do an equation. Let me give you an example. If we have a question, for example, such as 8 times 4 minus, let's do minus 4 divided by 2. Well, according to PEMDAS, I am supposed to do either division or multiplication first, depending from left to right. Okay. There is actually a much easier way to do this. You can use parentheses, as we have up here, parentheses, to make this a lot easier. We know that parentheses is the first order of operation, the first operation we must do. Exponents, and the question I just posted, we don't have exponents. We do have multiplication, we have division, and we have subtraction. If you recall, multiplication and division are interchangeable. Depending on which one comes first, from left to right, you do. And the same applies to addition and subtraction. Let's go back to our question. 8 times 4 minus 4 divided by 2. Well, if we follow the directions, I could do this first, right here, 8 times 4, which give me 32. Okay. Then I have subtraction, which I kind of have to save because I still have division, which comes before subtraction, according to the order of operation. But then how I would get stuck, because I would do this, and then I can't technically do this until I do this part, because this would turn into a 32. So how can I make this work? I need to use parentheses. So let's put parentheses around the areas that we want to do first. 8 times 4, 4 divided by 2. Now this is not necessarily going to happen every time. I'm just showing you a way of how parentheses will change your answer. Let's do this one first, and you can see the answer. 8 times 4, 32. Minus, let's just bring the minus sign down. 4 divided by 2, 2. Right? And now we have 32 minus 2 equals 30. Now watch how the answer changes when I put the parentheses around a different part. Okay, what's the question again? 8 times 4 minus 4 divided by 2. Let's say I decide I'm going to place the parentheses around the 4's. 4 minus 4 equals 0. So I have 8 times 0 divided by 2. Which one would I do first? According to PEMDAS, I have to do the multiplication first because it's from left to right. 8 times 0, 0. Oops. 0. 0 divided by 2, 0. So it really did change my operation completely. In one I got 30 and in the other one I got 0. So now you can see how parentheses can change your answer. That was the whole purpose of that. This you will have to do for question 2 on page 219. Question 219, on page 219, question 2, you have the equation 6 times 4 minus 2 divided by 2. That's the very first one. You can put brackets anywhere or parentheses and you'll see which answer you get. And you have to try this 4 times, 1 per line. So 6 times 4, you could do that as an equation first, or you could do what we did before, 4 minus 2 first. Okay. You could do any combination and just try them 4 different times and see which answers, how your answer changes every time you place the parentheses in a different spot. Before that, from question 1 from question 1 from A to D, all you have to do is just follow the order of operation to solve your question. Question A is 7 minus parentheses 2 plus 1. Right? Well, if we do the order of operation, we understand that we have to do parentheses first. So what's 2 plus 1? 3. And now you have 7 minus 3 equals 4. Go ahead and try that from B, C, and D. At the very bottom for number 3, you have to match the stories to the sentence, the number sentence. Okay, I'll let you try to figure that one out and see how well you read the sentences. Remember, order of operation, what needs to happen first and then what needs to happen next. Whatever happens first, remember to use parentheses so that you tell me that I have to do that part first. Okay, you'll continue with the same matching stories, story 1, story 2, and then number 5, story 1, and story 2 again, with the number sentences next to it. Okay, if it matches, just write a line straight across. If it doesn't, you might have to crisscross them. Continuing on with page 220 of your math journal, at the very bottom on question 6, you are given a story. For this story, you have to write a number sentence. You have not done this yet, so let's do it together. A grocery store received a shipment of 120 cases of apple juice. There's our first number, 120 cases of apple juice. A case is a box, okay? A box of apple juice. Each case contains 4 6-packs. So if each case in 120 contains 4 packs, and each pack contains 6, that means we also have 6. So I have 6 juice boxes. Okay, sorry, 6, apple juice boxes, correct? In each case, and I have 4 cases. And there are 4 cases in each box, and I have 120 boxes. So this is the operation. I want to know how many boxes of juice are in each big box. So that's why I have to multiply 4 times 6, because there are 4 cases. Remember, each case contains 6 boxes of juice. Okay. So where would I start? Well, I want to know how many juice boxes are in an entire big box. So I will just multiply these two. And that'll give me the total of how many juice boxes are in each box. But then it continues by saying, after inspection, after the shipment came in, they checked it, the store found that 9 cans were damaged. So after I get this total, I have to subtract 9 out of it. And there's our number sentence, boys and girls. That's our number sentence. That's what we need to do. Okay? 4 times 6, 24. So there are 24 juice boxes in one big box. And there are 120 big boxes. So we put that down, 120. We know that, and then minus 9. We know that according to PEMDAS, multiplication comes before subtraction. So I would do this part first, and then this part, and that'll give me my total. Go ahead and try that. Feel free to use a calculator for the 120 times 24. Next up, we have our math boxes on page 221. I will not go over that today because it's measurements, length and width, which you've already done. It's stem and leaf plots, degrees, and sales, by where you multiply by, you turn the percent into a decimal and you multiply it, and that'll give you how much money is off the actual price. So I will not go over that. I've seen that many of you have done it, and many of you have done it correctly. So let's jump on to using parentheses. 7-4 is the study link from the Math Masters. I uploaded this page. You will have to copy into your notebook. For number 1, we have to use parentheses to prove that this is a true statement. What it's saying here is that 2 is the same, or equal, it's the same as 3 times 2 minus 4 divided by 1. If we were to just do this without brackets, without parentheses, we would get a different answer. Let's try it. Let's just try it by doing, I guess, just PEMDAS without inserting brackets. So if we follow PEMDAS, we would have to do multiplication first. So it's 3 times 2, 6, minus, and then we do division next, right? 4 divided by 1 is 4. Oh, look at that. It's going to work. 4 minus 2 equals 2. Or we could just put it here, sorry. It worked this time. What if I decided to just do it without, let me move this out of the way. What if I decided to do it without following the order of operations? Let's see. 3 times 2 is 6 minus 4 divided by 1. 6 minus 4 is 2. 1 divided by 1. And then 2 divided by 1 is still 2. Okay, so it still continues to be true. This is actually quite easy. You wouldn't have to insert parentheses if you didn't want to, because you keep getting the same answer. This doesn't always work though. Sometimes you do have to insert parentheses, and you'll be able to see that when you do question 2. You'll see that you'll have to insert parentheses at one point. If I were to do this, I would insert the parentheses, for example, right here. So that'll always prove to be true, because this will give me 6, and this will give me 4, and 6 minus 4 is always 2. For question 4, you have to write the names, or what we call a number sentence that will always equal 8 using parentheses. For example, 2 plus 2 times 2. In order for me to do the addition first, I would have to place parentheses on it. 2 plus 2 is 4 times 2 is 8. So this is one valid number sentence that would equal 8 every time, and you can use that one if you want. You have to make, in total, you have to make 7 of them by using parentheses. If I didn't use parentheses, I would get 2 times 2 plus 2, which would be 6. So I have to use parentheses. Questions 8 to 11 are actually a bit difficult. We have done this before, not to this extent, because it's bringing together mixed numbers as well as a variable, and you have to try to isolate the variable and use inverse operation. I've explained what an inverse operation is before. Isolating a variable means you leave the letter on one side of the equal signs all by itself. Okay, like let's say this. Okay, now that it's here all on this side by itself, you can actually say that a equals 5. In order to do that, you have to do inverse operation. For example, over here, it might have been, let's say, negative 3 plus a equals 2. Maybe that was the original answer. I wanted a to be all alone, so I did an inverse operation where I left the a over here all alone. I took the 3, I brought it over. Because I brought the 3 over the equal sign, it changes its value to the opposite. What's the opposite of subtraction? Addition. What's the opposite of division? Multiplication. And so on. So this would change to addition. Oops. And then we could say a equals 5. Let's do question 6 together. You can try, we can do 6, 9, 10 together so that I keep you watching the video and you can try it at home. This will prove to me who's really watching the videos, because I know some of you out there are not watching them. Even your parents have told me that. Let's see, question 8. 2, 5, 15 equals bracket 1, 1, 12 plus a. Oops, I made a small mistake. It's not 5/15. It's 5/12, and now I can't erase it. Okay, I'll just rewrite it, move this one out. Okay, so we're back now. Okay, I went ahead and did the problem and did not press the record button as I was talking and explaining it. So I'll go over it again. Please bear with me and watch. Okay. We have to try to isolate a, as I have mentioned before, and it's already on this side, so let's leave it there. Over here we have 1 and 112. 1 and 112 is positive because there's no negative sign here. So what I have to do is just bring it over to this side, and when I bring it over to this side, a positive number changes into a negative number. And that's what we have down here. We have 2/15, which I just brought down, just left it on the same side. Now we have minus 1 and 112. Because I brought it over from this side, so it turned into a negative, equals a. And then, because the fractions have the same common denominator, I can just work straight through. And the numerator here is higher than the numerator here, so I can subtract it straight through. What is 2 minus 1? 1. 5 minus 1? 4. And then the 12, because it's the denominator, stays at 12. 4 over 12. We're not done. We can reduce that. Here's 1 4, and in this 12 there are 3 4s. So 1 over 3. 1 1/3 equals A. For question 9, we have to try to do the same thing. Let's try to isolate our variable. Our variable, remember, variable is a letter. Here's our letter P, our variable P. It's on the more crowded side. The 12's over here all lonely on after the equal sign. It's lonely. You would think it'd be easier to just bring this 12 over here and take the P over there and then solve. No. Fortunately, that's not the way it works. We have to take everything that is very crowded on one side and bring it over to the other side. So let's start. I'll start by taking over the 2 to the power of 2. Bring it over. On this side is multiplication. What will it be when I bring it over here, over to this side? Well, if you said division, you are correct. Okay. So it's really going to be divided by 2 to the power of 2. Let's do the exponent, which would be 4. All right, 2 times 2 is 4. Now it's really turned into 3. The next thing I need to bring over is the 1 1/2. On this side, the 1 1/2 is positive. You don't see a negative sign in front of it, so it's positive. You just assume it's positive when you don't see a negative sign. Once you bring it over all the way over here, it becomes a negative. So, negative 1 1/2. Or we could also say 1.5 is 1 1/2. Well, what's 3 minus 1 1/2? 1 1/2. Right? Because 1 1/2 plus 1 1/2 is 3. And there's our answer. P equals 1 1/2. Okay, go ahead and try 10 and try 11 on your own. If you don't get it, just really try to follow the order of operation and try to reflect on what we did here. Remember to invert. Invert operation is when you go all the way. You throw one number to the other side of the equation and you change its operation. If it was multiplication, it becomes division. If it was addition, it becomes subtraction. Or if it was positive, it becomes negative. For the next page, reviewing parentheses, we're given the sentence, Mary Grace the lizard ate 3 crickets. Now the reason we're given this sentence is to try to explain how parentheses can work kind of like commas. If we don't use commas in this sentence, it might be hard to understand. Let me show you the example. Let's say that Mary Grace the lizard ate 3 crickets. We kind of have, in this sentence, we have 2 subjects. Mary Grace and the lizard. Mary Grace the lizard. Is that just one subject? It's all just one? It's hard to understand. Or is Mary the subject and she's talking about Grace the lizard? Let's see how many meanings we actually get. I'll just say Mary Grace is the girl. Mary Grace. And now we're telling her. The lizard ate 3 crickets. Mary Grace, the lizard ate 3 crickets. Or we could say Mary Grace, the lizard. If we put another comma here after lizard, right here, now we're saying that the lizard is Mary Grace. Mary Grace, the lizard, ate 3 crickets. Just giving a little more information about who Mary Grace is. But now let's say I decide to put a comma, let's see, right after, let's say I decide to put it right after Mary. So now I put the comma here. Mary, Grace the lizard, ate 3 crickets. Now Grace is the lizard. So you see how commas can really change the meaning of a sentence, especially one that looks to have 2 subjects, or it might be all one subject. Okay, 2 names, and we don't really know who they apply to. The same thing works for brackets or parentheses. For question 2a, we have 3 times 4 plus 7. equals 33. According to the PEMDAS order of operation, I should do from left to right, right? And especially I should do multiplication before I do addition. Let's try that. If I do 3 times 4, I get 12. Plus 7, what's 12 plus 7? 19. So is this statement true? Nope, that's not 19, it's 33. How can I make this so that it equals 33? Where could I put my parentheses? Well, let's say I could do 4 plus 7 first. Would that work? Well, it's 4 plus 7. It's 11, right? Times 3. What's 3 times 11? Ching-ching. There is our answer. So do that for B, C, and then try that to insert parentheses in the expressions below and find the solution. Try that for A and B of number 3. You could do a couple of them for each one, and you'll see that you'll get a different answer every time. For our last page, we have a pattern of dots, and they want the book wants us to take this pattern of dots and break them up so that we make a number sentence. Let's see. If I were to do this, according to the example, I could, for example, draw a box so that I cut out all the single dots on the furthest part out. That would make a plus 4 in my equation, because eventually I will have to add those back in. So there's plus 4. I'm just putting those to the side. Let's continue. Now I can see that I have 3 right there, I have 3 right there, 3 right there, and 3 right there. So I could say that is 3 times 4, right? So I have 4 groups of 3. Okay, 3 times 4. And what do I have left? There I also have, now I have 3, 3, and 3. So I have 3 times 3. And I'm going to add that to the rest. And there's my number sentence. 3 times 3, it's this middle part, which would give me 9. Plus 3 times 4, 3, 3, 3, 3, which is 4. 3, 3, 3, 3. Okay, 3 times 4 is 12. So 9 plus 12, 21. And then remember I added those 4 at the very end to the very side right there. So how many dots do I have? Looks like we have 25 dots. Now you have quite a challenge to do there. You have to try that with the largest one, with the largest array or pattern of dots. It's quite large, but try the technique that I just did and see if you can make one. You could take those corner spots and make them into small triangles of 4 dots. 1 dot at the top and 3 at the bottom, and that follows the same pattern all around. See, however, you can break it up and just make a number sentence. Alright, it's an open answer. You can have a lot of different types of answers. Good luck, and shoot me any questions you may have.